In Chapter 8, we learned that the graph of equations in the form ax squared plus bx plus c equals y. Actually, we usually thought about it as y equals ax squared plus bx plus c, but it's the same thing, has the shape of a parabola. The graph is a parabola. We learned this because this is a quadratic equation, and all quadratic equations have that shape as their graph. Last night, we also learned that when ax squared plus bx plus c equals 0, we can solve the equation using the quadratic formula. We actually have other ways of doing this as well. But as you can see, when we line up these forms, the only thing that's different is in one, we're saying y because it's all of the points that make that equation true, all of the x's and all of the y's. But when we're solving this equation, we're really finding the solutions, or the x's, that will make the equation equal 0, will make y equal 0. So what that means is the solutions, otherwise known as roots, of quadratics are really the numbers, or the values for x, that make y equal to 0. And if you think about our coordinate graph, we're looking for any x whose y is 0. That is code for all of the points on the x-axis. So when we're talking about the roots, we are really talking about the x-intercepts, the places where the graphs cross the x-axis. Closer look at how that will play out. Since we know the shape is a parabola, we can see that this is a good reason why most of the ones that we talked about last night had two solutions. Because if I have a parabola that looks like this, it's crossing the x-axis in two places, meaning it has two x-intercepts, otherwise known as two solutions. If I drew one like this carefully, and it just reached as far, the vertex is on the x-axis, it's only touching the x-axis in one place, so it would have one solution. And if I drew another one that never crosses the x-axis, it has no solutions. So this one has two solutions. This one has 0 solutions, or no real solutions. And this one is a picture of one solution. I also want you to call to mind the fact that when we have ax squared plus bx plus c equals y, when a is positive, the parabola smiles. In other words, it opens like this. When a is negative, and a is a very specific number, it's the coefficient of the quadratic term. When a is negative, it frowns. In other words, it looks like this. So with that basic groundwork laid, it's a part of the quadratic formula, the part that goes under the square root bar. That's b squared, and I like to say plus negative 4ac. And this is called the discriminant. So just like when we are solving quadratic equation, discriminant, just when we're solving quadratic equations, if we figure out what a, b, and c are, and then we plug them into this, that will give me the discriminant. And the reason why the discriminant is helpful is because when b squared plus negative 4ac is positive, I was about to say is greater than 0, which I guess is the same thing, is positive, that tells us there are two solutions. When b squared plus negative 4ac equals 0, there is one solution, which is actually called, it's a double root. It means that this is a perfect square. Like if I tell you that x minus 3 times x minus 3 equals 0, well, there are two solutions, but they're the same number. They're both 3. So that's called a double root. And what it means is this, if this equals 0, then the thing that you're talking about, the quadratic equation, is a perfect square. Because generally the highest exponent will tell you how many solutions there are. But finishing this out, when bx squared plus negative 4ac is negative, it means there are no solutions. So let's just do a few examples to look at how this plays out. That the equation is x squared minus 5x plus 7 equals 0. Remember, we're talking about ax squared minus bx plus c equals 0. So just like before, I can say a is 1, b is negative 5, c is 7. So to plug it into the discriminant, I say b squared, that's 25, and then under here I'm going to say negative 4 times 1 times 7. So this is negative 28, so I'm going to say negative 28. That is equal to negative 3, and since the discriminant is negative, that means there are no solutions. Well, and the other thing you have to be able to figure out is where the vertex of this would lie. So, if I know that A is positive, and it is, then I know I have a smiler. And I know there are no solutions, which means it must be above the x-axis. So there are no solutions, and the vertex is above the x-axis. This one I'm going to write out the way they have it in the book. Y equals negative x squared plus 3x plus 6. So A is negative 1. We know it's going to be a frowner. B is 3. C is 6. B squared is 9. And negative 4 times A times C is positive 24. Since this number is positive, that means there are two solutions. And all that's left to find is where the vertex is. If I know there are two solutions, and this is a smiler, the way to get it to cross the x-axis twice is to have the vertex below the x-axis. And that's our last lesson in this Algebra 1 course.